For the next few analysis assignments, we're going to be using data from the Household Pulse Survey. The Household Pulse Survey is a survey conducted every few weeks by the US Census Bureau in response to the COVID pandemic. It's a very rich data set, and we're only going to be using a part of it, but you're welcome to dig into it further if you have the inclination. There might even be an interesting project or two buried in there. In the videos for the next few weeks, I'm going to use an early wave of the survey, and I encourage you to download the same data file so that you can follow along with me. Then, in the associated analysis assignments, you'll perform a similar set of tasks on a more recent wave of the data, and in some cases, you'll compare your findings to mine. So, how do you get it? Go to this website, www.census.gov/programs-surveys/household-pulse-survey/datasets.html. And once you're there, scroll down the page. Let's pause for a moment here. The very first data set you come to under Household Pulse Survey PUF, which stands for Public Use File, July 27th to August 8th. This is the week 48 data, and as of this recording is the most recent data file available. You'll be pulling your data for the assignments from here. But if you want to follow along with the videos, and I strongly suggest you do because learning by doing is a much better approach than learning by passively watching, then you want to scroll much further down until you reach, near the bottom, Household Pulse Survey PUF for August 19th through August 31st. So this is only a few months into the pandemic. Week 13. And in particular, we're going to take the one labeled CSV. So if you click on that, it should start a download for you. Depending on what browser you're using, it will show up in different places. It'll take it a moment, but you're downloading a zip file. Once that file has downloaded, go ahead and open the containing folder, and then you want to extract that. So if you're in Windows, you should see an extract all features. Mac should have something similar. Just follow the prompts to be able to do that, and eventually you'll have it in its own folder. Make sure you specify the folder to be wherever you're storing your files for this class. Do not try to open the actual data objects in Excel. Yes, it looks like Excel can take it, and technically it can, but Excel will not be happy. These are really meant to be used in a statistical software program like R or SAS or Stata or SPSS. You could, if you wanted to, open the one labeled Data Dictionary. If you do, this is what it will look like. The Data Dictionary can be a little bit weird to read at first, but the basic idea is there's one column for all of the variable names. This tells you the name of the variable in the data object. There's a couple of columns describing that variable. It tells you what it is, it tells you what the values mean if it had to be coded to something, and a few other useful things. And there's a column that tells you exactly how that survey question was worded. So you might at some point need to go in here and dig some things up. I am going to show you in a moment on some slides the questions that we're going to be working with, so don't worry about that too much for now. So once you have the data downloaded, go ahead and open up RStudio and start a new script file. Go ahead and either set your working directory or create a file path object, as I have done here, and then you're going to load two libraries. You need the Tidyverse library and the OpenXLSX library. Go ahead and run those things, and then once that's done, the last thing to do before we take a moment to look at the variables is to load your data. And we're going to do that with the command read.csv. And if you're using the object approach that I'm using, then you can do file.path and then the name of your file path. And then the file is pulse2020_puff_13.csv. If you're using an approach where you set your working directory, then within the read CSV, all you need to do is the quotes and then the name of the file. Let's review the variables we're going to be working with. There are, of course, several sociodemographic variables of interest, such as race and ethnicity, gender, age, education, income, household size, and even location in the country. And then there are several substantive questions of interest, and there's plenty more than this. These are just the ones we're going to focus on in this video and in the assignments. We're going to look at food sufficiency. We're going to look at spending on food. There are 2 questions each for both of those topics. We're going to look at one around difficulty with expenses in our next assignment. And also in our next unit, we're going to look at a few on mental health. And in your assignment, when you look at week 48, you'll get to look at some that are around experiences with COVID and the COVID vaccine. Let's walk through each of these so you understand what they look like. Race and ethnicity is composed of 2 variables. This is common for the census. There's one on race and one on Hispanic ethnicity. And they are coded as follows. For the Hispanic question, which is labeled R Hispanic in the data file, 1 is not Hispanic and 2 is Hispanic. And then for the race variable, which is R race, that's R for respondent, 1 is white, 2 is black, 3 is Asian, and 4 is any other race or any combination of races. Gender has a variable that is 1 for male and 2 for female, but by week 48, this was changed. And there is a variable for gender at birth, for their gender currently, and then a related one, although it's not gender, there's also a question by then on sexual orientation. Age is not directly in the data set, but they did ask for the respondent's year of birth, and we can use this to calculate age using a simple mutate, and I've given you examples of that on the screen, and we'll do that in our video too. Education is, of course, coded as an ordinal variable, ranging from less than high school all the way to graduate degree, and you'll see too that they've got a few more categories than we talked about in our last week video. Similarly, income is coded as a set of ranges, making it not ratio, but ordinal. And now we also see that it's possible for this to be missing. People might not have answered it. We'll talk about that more in a moment. Household size has 3 variables, 1 for the total number of persons, 1 for those who are under the age of 18, and then 1 that the census recoded themselves for the number of adults in the household. And then there are 2 variables for location. EST_ST is the state. Pay attention to Tennessee, which is number 47. We are going to be doing stuff with our home state. And then if you want something a little simpler, they've also recoded that into one called region, which is simply one of the 4 major census-designated regions of the U.S., Northeast, South, Midwest, and West. And then here are our substantive questions. We have one on food sufficiency, which asks, in the last 7 days, which of these statements best describes the food eaten in your household? Enough of the foods that we want to eat, enough but not of the kinds we want to eat, sometimes not enough, and often not enough. And let's talk for a moment about these last 2 options, the -99 and the -88. These are different forms of missing variables. In a survey, you will very often hit the issue of having missing data. In other data sets, you may have to deal with things a little bit differently. It might be coded in a different way. But they've actually made it very convenient for us by scoring them as negative numbers. I'll show you in a moment here how you can basically use a filter to capture anything greater than 0, or sometimes greater than or equal to 0, and it will immediately kick out the missing data so that you don't have to worry about it. But if you encounter issues of missing data in other data sets that don't look like this, and you're not sure how to deal with it, feel free to drop me a line and I'll do my best to help you out. Okay, there's one other question on food sufficiency. This is looking specifically among children. The children were not eating enough because we just couldn't afford enough food, and they're asked to respond their level of agreement or truth with this statement. Here, the order is reverse of what we saw. 1 is that is often true, meaning there's more food insecurity. 2 is sometimes true, and 3 is never true. And then we have 2 questions that are the few questions in the data set coded as ratio variables. These are both on food spending. Household money spent in the last 7 days on food to be prepared and eaten at home, and household money spent in the last 7 days on prepared meals. And they entered an amount. If we were to look at this, we would see that a lot of people are estimating particular amounts, so it's maybe not a perfect ratio variable, but it does give us enough variation that later we'll be able to do some stuff with this to play with that. Let's try making a frequency table of the food sufficiency questions. If you think back to last week, we have a technique for that. You can do the name of the object, piped into group by, in this case our variable is the cur_food suff, and then piped into tally. And then we could, of course, continue this out to get the percents. But we also need to make sure that we have filtered out the missing variables. Thankfully, since we're working with a piped arrangement, that's pretty easy to do. So if we come up here before the group by variable and enter down 1, and then add this filter command, we're going to filter by cur_food suff is greater than 0, because our missing values are negative. The values of interest are 1, 2, 3, and 4. If there were a 0, we'd just make that greater than or equal to. And then we can run this, and we should get an output that looks something like this. Let's copy that same thing over again, but this time replace the variable with the one for child food sufficiency, and that's child food. And there are 2 places to replace that, and then you can run it, and you get a table like this. So, what do you notice here? What's going on? Remember that we should always be thinking about how we interpret our findings. So if we look at overall food sufficiency, it looks like somewhere around 7% of the population identified what we might call true food insufficiency, that the third and fourth values are they sometimes go without food or they often go without food. With 2, it's they get the food they need, it just might not always be what they want, which is kind of a moderate place of in between sufficiency and insufficiency. And then the first one is getting enough food of the types they want. And then down here for the children, it looks like almost 5% of kids are reporting not having food, often going without food within the last week. And then just as a refresher, let's do this same thing again for our ratio variables, the ones on food spending. Keep in mind in this case, food spending could be 0, so we want to include 0 when we filter out the missing values. And note that I got an error. Sometimes that happens. Don't panic if that occurs. I'm leaving this in so that you can see how to deal with that. It's telling me that it had an unexpected symbol. When I look at it closely, I see I forgot to put a comma. And there we go. We'll just keep it there for now. We could add the quartiles and we could add the standard deviation, but I just wanted to review to get the idea. And you could copy this and do it again using the spending variable for prepared food. So, food spending tends to be somewhere in the $160 to $200 range at average, and prepared food spending is somewhere in the $50 to, say, $75 range. Let's turn back to graphics, and I want to spend the rest of our time thinking through how we can really make graphics that pop and sizzle. So let's start by returning to a basic one that we've already talked about. Let's make a bar chart of household size. And fortunately, that's pretty easy to do, and there's no missing data in this variable, so we don't really have to worry about doing anything special just yet. Here's the code, and when we run that, this is what we get. So the codebook says that it could go up to 40. It seems like it capped out at 10. And while we could make that a histogram, I mean, technically it is a continuous variable after all, really we might be better off clustering the data non-uniformly, because look at the right side of that graph. That just becomes a little bit meaningless to see. So to do this, we can do the adjustments upstream and pipe it into ggplot. So start up here at the top with our object, and we can pipe that first into a mutate function. And what we're going to do is we are going to mutate this variable into something we're going to call household, and we're going to do it based on the size of the total household number of people. And we're going to do that using an if-else statement. An if-else statement is really useful for making these kinds of comparative evaluations, and it has 3 parts. The first is always a logical expression to evaluate, then what to do if the expression is true, and then what to do if the expression is false. And what we're going to do is we're going to collapse this variable such that if the variable is less than or equal to 4, we're going to keep that value. But if it's 5 or greater, then we're just going to say, call it 5, and then we're going to do something else with it. Because next, we want to add another line to our mutate. Now, we're going to add this other line basically to make this a factor, because otherwise we're still going to have the 1, 2, 3, 4, and 5. And we need to adjust that. So if we do household equals factor of household, and then add the argument levels equals, and you see I've just put them in order here, and the default is to order them in the sequence given, which we want. So we'll take single person, 2 people, 3 people, 4 people, and 5 or more people. And then I found that I actually had a typo here. Instead of levels, that should actually be labels equals. So fix that. And then before we go any further, we also want to go ahead and put this as a percent. And we can use the old code that we've done before. We're going to pipe that directly into a ggplot. The key difference now is because we're piping into it, we don't need to name the object. It's going to take everything from above that's being piped in and treat that as the current object to work with. We're also going to need to make one more change from what we've done before. We're going to have to swap out geom_bar for geom_call to make a actual column graph instead of a bar graph. And geom_call requires both an X and a Y. But this is good because now we can use X as our household variable like we've done before, and Y as the percent. And so when we run that, this is what we end up with. This is getting a lot better. Let's see if we can clean up the labels a little bit. After the geom_call, add a plus, and then add a new line and add labs. This is actually short for labels, but I pronounce it labs. And then within that, we're going to give X the title household size, and we're going to give Y the title percent of households. And then let's also add a title, distribution of household sizes in the US. If we want to make this really pop, then we can start to play with the theme. And you can add this really anywhere after the geom argument. I am particularly fond of theme_BW for black and white, but as you can see, there are plenty of others that you are totally welcome to play with. Finally, let's give the bars a different color. In the geom_call line, add fill equals, and then you can give it a color name if it's in R's known palette, or you can give it a hex code. I'll show you both throughout this video. Right now we're going to go with a color. I'm particularly a fan of dark red, but there are plenty to choose from. And if you go to this website, r-charts.com/colors, you will see that there are plenty of colors, both by name and by hex code, organized by different shades and hues that you can play with. Let's turn to a continuous variable and try doing this with violin and box plots. Use the tbirth_year variable to calculate the respondent's age. And we can use a mutate and subtract this from 2020 to get their age. Remember that in the week 48 data in your assignment, you should subtract from 2022. Now pipe this into the code for a violin plot. Make X equal to factor of E gender and Y equal to age. And the code book tells us that 1 is men and 2 is women. And we need to clean this up. We can do that by adding scale X discrete after the geom command. And in that, we add gender to give it a clear axis label. And we also add labels equals C, which stands for concatenate, parenthesis, and then men and women, both in quotes and separated by a comma. And that will mark the values correctly. Let's also use some of the other elements that we've learned to give the plot a title and a nicer background, clean things up just a touch. And then let's color the 2 violins. And to do that, we will also need to set fill equals factor of E gender. We get a legend, and we get the R color defaults. So let's take care of these things. We don't need a legend in this case because we've already labeled it. So remove the legend with theme, parenthesis, legend.position equals none. And to get colors, add a line scale fill discrete, and then inside the parentheses, type equals concatenate, and you can choose any colors you want. I am going with Firebrick 2 and Goldenrod 1. And as a note, if we had this on continuous data, you would instead use scale fill continuous, and instead of type equals, you would put values equals. Let's do one more. Let's do a bar chart for food sufficiency using the variable cur_foodsuff. Start by making one for the nation as a whole. Remember, we need to filter out the missing values, and we're going to go ahead and do this as a column graph. So make your frequency table as you did before, and then pipe that into a ggplot. X equals the variable of interest, Y equals the total, and then you can plot this. Let's make one more adjustment real quick, though, to get that on the percent basis. All right, now let's say we wanted to compare two states to each other. That group by needs to change slightly and gain a variable in front of it. So we're going to put state and then the variable of interest. Then we also need to add one more group by variable after we have ungrouped from that to regroup just by state. Now, after the mutate line, add a filter. Remember that our code book tells us that Tennessee is state number 47. And for our example, let's compare ourselves to Kentucky, which is state number 21. And we also need to make two other changes to the graphics code. Add fill equals factor of EST underscore state to the AES section, and add inside the geom call position equals dodge. Don't forget to make sure everything is properly piping into the ggplot. All right, now let's add some code to clean things up just a bit. This time, we do need the legend, but it needs to be relabeled, and we should probably move it to the bottom where I think it would look better. So do that last one first by adding theme of legend.position equals bottom. We also need to better identify the states of interest because Tennessee is state 47. What does that even mean? Let's do that with a mutate before we get to the ggplot, but it's going to need to be separate from the other one, or you'll confuse R in this case. Then remember to change out the fill equals argument to instead equal this new variable that we've made. Now let's turn those numbers in our variable of interest into useful text. The x-axis categories can be done with scale x discrete, labels equals, and then we fill in the appropriate labels. We'll have to use the code book to manually write those in. We also need to wrap factor with parenthesis around the x variable in the AES line. Now add some labels and some helpful titles and subtitles using the labs command. And finally, let's pick some better colors than the default using the scale fill discrete command. And we'll make a few other tweaks and adjustments until we finally get something that we like. The idea is you can play with this until you get it just so. Technically, we've, again, moved into bivariate analysis, but shh, don't tell anyone. As a precursor to what we'll formally pick up with in a few weeks, let's take this a step further. What if we wanted to compare Tennessee to several other states? There are several ways we could do that. We'll save the mathematical ways for a few weeks, but for now, I'll show you two graphical ways. Option 1 is to pick all of your states of interest into the same graph. If you don't have too many states, that might be a good choice. You'll need to make adjustments to your code in any place that references states. So to simplify for this example, let's just comment out the line with the colors. And adjust the mutate, replacing Kentucky with paste parenthesis EST underscore ST. This is not a true fix, but you'll see why I'm taking the lazy route in a moment. Then change your filter command to read as follows. This is going to be for all bordering states of Tennessee. Filter EST underscore ST, parenthesis in, concatenate, and then the values 47, 1, 5, 13, 21, 28, 37, and 51. As we might expect, with 8 states, it's a bit cluttered and hard to read. This approach really only works with a small number, so we could reduce the list, but I wanted you to see the technique for 2 reasons. First, it shows you how to put simple comparisons onto one graph, and second, we're going to build on this for option 2. Option 2 is to make a graph comparing Tennessee with each other state in our list, one at a time. To do this, we need to put our graphing code into a function. Then we'll use that function inside a loop to generate our 7 graphs, one for Tennessee versus each bordering state. That's a lot of steps, so I'll break that down for you in a moment. But before we do that, let's fix a few things from the changes we just made. In the mutate line, add Kentucky back in, uncomment the line for color. That list of numbers from 0 to 51, drop that back down to just 21. And as a quick reality check, run that to make sure it works. Yes, we're back to Tennessee and Kentucky. Now, write the function. In the line above the code, enter down a bit and type function, parenthesis, space, curly bracket. Inside the curly bracket, enter down a bit. Highlight all of your code and cut or copy and paste it into the curly braces. Up on the line with function, you need to add 2 things. First, let's store this function into an object, and I'm just going to call it state food. Now add your variables for the function, and we need 2, a state ID and its name. And you can call these anything you want, but it's usually a good idea to keep it something at least intuitive to understand. Then put these variables in for the 21 and the Kentucky in the code. Now run the function, and it should show up in your environment. Before we write the loop, we should create an object containing our states and names. Since the data only have numbers for each state, we'll have to do this manually. Start by writing states, and then we're going to store into this object a tibble with ID equals, and then concatenate. And then on the next line, don't forget the comma, name equals, and concatenate. And then we're going to need to fill in the values for each of the concatenates. Use the sequence of numbers that we did from before, 0, 1, 0, 5, 13, 21, 28, 37, and 51. And then add in the matching state names in order. Those are Alabama, Arkansas, Georgia, Kentucky, Mississippi, North Carolina, and Virginia, the states that border Tennessee. Now write the loop. A loop carries out a set of instructions iteratively until told to stop. There are 2 kinds of loops, for loops and while loops. For loops repeat a certain number of times and stop when they reach the end of a pre-specified set of values. While loops repeat as long as a condition remains true. When the condition is no longer true, it stops. We are going to want to build a for loop and specify the states of interest. After you generate the states object, type for, and then you'll see options, let it autofill. We need to add things for variable and vector. I'm calling my variable I, since we're just doing a simple count. And in place of vector, type 1, in row, parenthesis, states. This is saying to work through each row of the states object one at a time. And if we run just that part, you'll see it gives us 1 through 7, the number of rows, the number of bordering states. Within the brackets of the loop, add this code. Print, parenthesis, state food, parenthesis. And you'll see it prompts us for what variables were needed for this function. We're going to put states $ID bracket I, comma, states $name bracket I. What we're doing is we're using our graphing function that we made, drawing on the ith row of each variable in the states object to generate it, and then inputting those particular values each time around. Note that we have to wrap this in a print function, or R will not output the graphs that it generates inside of a loop. Okay, we should be ready to run this loop now. To see them, we can use the left and right arrows in the plots pane. This leads us to your next analysis assignment. You are to pull in week 48 data and replicate some of this output. You'll compare data from that wave to the things seen in this video. You'll generate a few graphs, maybe not exactly the same as I just did. And week 48 also has some questions about experiences with COVID to explore. And remember to take time to interpret your output. Really, Take your time in general. Learning R is filled with mistakes and errors, and the best approach is to be very, very methodical. Do as I've been showing you. Build your code in tiny pieces at a time, checking things as you go. And if you run into trouble, drop me a line and I'll try to help. Include a screenshot of the code and the output error for me to be the most effective in helping you.